Hey guys, welcome back for our new semester. We're going to start with target 5A. Use the rules of probability to compute probabilities of compound events in a uniform probability model. Don't really pay attention to that. Really what we're focusing on in this video is 5A.1, our mastery learning objective, which says I can calculate simple probability by creating the ratio of favorable outcomes to total outcomes. So all probabilities are ratios, and the biggest thing to remember is that a ratio, this word right here, that just means it's a fraction. We kind of looked at some of these, right, the word ratio in first semester when we looked at rational, right? Rational numbers can be written as fractions, so it's the same idea here. So all of your probability stuff is going to be written with fractions. So that's a big important thing to remember for this whole unit. Okay? So what is probability? The definition of probability is the likelihood of an event occurring. The likelihood of an event occurring, or how likely it is for something to happen, right? And how we find that is through a ratio, a fraction. So the probability of an event, can't spell, is, what we say is the number of favorable outcomes over the number of total outcomes. Okay, and favorable outcomes is kind of a weird term because it might not just be good things, right? It's just whatever you want in that moment, right? I can say the probability of wearing blue socks, right? Then my favorable outcomes would be all my pairs of blue socks, where my total number of outcomes would be all the socks I own, whether they're blue or not, okay? So that word favorable is just really what the question is asking about. All things fall in a spectrum between impossible and certain. So an impossible event cannot happen. Okay. And the probability of the impossible events is 0. The probability of an impossible event is 0. It will not happen at all, which is the same as 0%. That's easy. A certain event is, it has to happen. It will always happen no matter what. There is no way it is not going to happen. It is certain that it's going to happen. And the probability of that is 1, which equals 100%. Okay? So then any other event has to fall between 0% and 100%. You cannot have something have 150% probability of happening. Okay? What this will really help you with is checking your answers on some of quizzes, tests, homework. If you get a probability that is greater than 100%, it's wrong. Sorry, but your answer is wrong. You can't get that. And if you get like a negative, it's wrong. Okay, so knowing that it has to be between 0% and 100% can help you check some of your answers. This last one is just a notational thing. This P, then parentheses with event, just means probability of event. I'm going to underline that event because we'll replace that word event with the thing we actually want. You can already see it in like these questions down here. It's not event, it's purple, yellow, right, of what's actually happening. Okay, so don't say P parentheses event. That's not what it means. Probability of whatever. Okay. So you have 4 red, 6 black, 3 blue, 2 yellow, and 5 purple marbles. Okay? And we're going to find all of these probabilities. Okay? So again, probability all has to do with the probability, the number of favorable outcomes over the total number of outcomes. Okay? So the first thing we need to do is figure out how many total marbles we have. Well, I have 4 red, and 6 black, and 3 blue, and 2 yellow, and 5 purple. If you add all these up, we have 20 marbles. So if I'm looking for the probability of purple, well, the probability of purple, use purple, is going to be the number of purple over the number total. Well, we have 5 purple over our total is 20. We just found that, right? So we have 5 divided by 20. We are always going to check with our calculator to see if we can reduce this fraction. So I'm just going to do 5 divided by 20, right? And we get 1/4. So there is our probability. 1/4 of the time, I will pick a purple marble. We'll go down to letter B, the probability of black. Oh, same idea. We're going to have the number of black marbles over the number total. We have 6 black marbles over, again, our total is still 20 marbles. I'm going to check if it can reduce in our handy-dandy calculator. 6 divided by 20 gives me 3/10. Okay, so 3 out of every 10 times I pick a marble, it should be a black marble. Part C, black or blue. We'll do the number of black or blue over the number total. I'm going to start writing 20 there. Number total. And with this, right, I'm looking for black or blue. So I have 6 black. We already knew that. So I can pull those, but I can also pull out the blue ones. And there's 3 of those. So I have to add those on to my 6 black that are a possibility. 20 is still our total. 6 plus 3 is 9 out of 20. Okay? This cannot reduce. You can type in your calculator to check, but it doesn't reduce, right? It stays the same. So we'll just circle that 9 out of 20. Okay? From here on out, I'm not going to pull up the calculator just for sake of time. I believe in you guys and that you can divide using your calculator. All right, moving on. The probability of yellow or red. So that is the number of yellow or red over our number total, right? Well, if we look at how many yellow marbles we have 2 yellow. And we have 4 red. And then we still have 20 marbles total. Okay. So again, 2 plus 4 is 6 out of 20. And that does reduce to 3 out of 10. All right, looking at the probability of orange. That's the number of orange out of the number total. Well, I have red, I have black, I have blue, I have yellow, I have purple. I don't have any orange marbles. And so if we don't have any, right, then I have 0 orange marbles out of my 20 total marbles. And if you do 0 divided by 20, 0 divided by 20 is 0. This is an impossible event. I cannot possibly reach into my bag of marbles and pull out an orange one. It has a probability of 0. Okay. Last one. Red, black, blue, yellow, or purple. I'm not going to write all of these things down. But I have 4 red. We have 6 black. We have 3 blue. We have 2 yellow. And we have 5 purple marbles. All over our total of 20. So 4 plus 6 plus 3 plus 2 plus 5 is 20 out of 20. Right? If you add all those up, you get 20. And 20 out of 20, 20 divided by 20 is 1. This is our certain event, right? If I say I can get red, black, blue, yellow, or purple, well, that's all there is in the bag. If I reach in and pull out a marble, I am certain to get one of those colors. Okay. All right, go ahead, turn the page real quick. We are now going to look at our die. Right? So we have a fair 6-sided die. Die is the singular, dice is plural. Okay? The reason I wanted to do these examples is because these are the ones where students mess up the most for like a silly mistake. So just always be careful when the event is a number. Okay? If I want the probability of a 2, that is the number of 2's out of the number total. If you look, here's my 2. I have 1, 2. How many sides of a dice total do we have? 3, 4, 5, 6. The probability of getting a 2 is 1 out of 6. A lot of people write this. They see the 2 and they want to put a 2 there. That is wrong. Don't do that. No. I'm going to put every X through it possible. Okay? Just be very careful when your event is a number, because we have the, it's already in your mind, you just want to write the 2 down, and it's not 2. It's 1, 2 out of 6. Okay, same thing with the probability of 5, right? It's the number of 5s divided by the number total. Well, same thing. I have 1 5 out of 6 total. All right, so it's not 5 out of 6, it's 1 out of 6. Just be careful. C, probability of even. Okay. Number of evens divided by the number total. So if you have evens, we have 2, 4, 6. So 1, 2, 3 options out of 6. This one does reduce, and we still always have to think we have to reduce our fractions. Probability of prime. We're going to define prime over on the side. A prime is a number divisible by 1 and itself. Okay, so for example, my prime numbers here, right, when I'm doing this, I'm going to do the number of primes over the number total. 2 is a prime because the only things that go into it are 1 and 2. 3 is a prime because it's only 1 and 3. 4 is not a prime. It's 1 times 4 and 2 times 2. It has that other factor. 5 is a prime. 6 is not a prime. It's 1 times 6 and 2 times 3. Okay? So 2, 3, and 5 are my only primes. And that does reduce to 1/2. 1 is not a prime because it's just 1. It doesn't have like another number there. Okay. The probability of not 4. Well, number of not 4s and the number total. Well, 1's not 4, 2's not 4, 3's not 4, oh, 4 is 4. We don't want to count that one. 5's not 4, 6 is not 4. So we have 1, 2, 3, 4, 5 numbers that are not 4 out of our 6. And finally, the probability of 1 or even. Number of 1s or evens over the number total. This is my only 1. And our evens, right, were these squared 1s. So there was 3 of those out of 6. 1 plus 3 is 4 out of 6, which reduces to 2/3. All right, that is it. Go ahead, start working on your activity.